Okay, let's look at a clustering. Probably one of the best examples could be found in a marketing. So, for example, if you want to create a business strategies for your market, especially if the size of the market is huge, you don't want to have only one marketing strategy for the whole market. So what we may want to do is you divide the market and then create a business strategy for each the those market segmentation. So market segmentation is very effective when you try to build the strategies for the homogeneous the clientele. Okay, so idea is well, how are you gonna do it? Okay, let's look at cluster. The cluster is a collection of data objects. So what you want to do is we want to have a similar object within a same group and dissimilar objects in a different groups. Okay, so the cluster analysis, sometimes known as clustering or market segmentation or data segmentation. So what it does is finding similarities between data according to characteristics found in the data and grouping similar data objects into clusters. So simply speaking, we want to have a similar objects in the same cluster. Okay, and this is probably one of the best examples about unsupervised learning. Okay, so there's no predefined classes. So for example, when you do a market segmentation, nobody has a market segment number on there for it. Okay, you have to create a market segments depending on the values of the attributes. Okay, and the typical applications, it can be used as a standalone tool, but also it can be used for pre-processing step. For example, before you use let's say regression or decision tree or neural network, you may want to divide a huge data into several or multiple homogeneous clusters, and for each cluster you may want to apply any data mining algorithms or regressions. Okay. Once you have clusters, and how do you know those clusters are good or bad or better? Okay. So let's take a look. A good clustering method will produce high quality clusters. So what that means is a high intra-class similarity. So in each cluster, the data should be cohesive or homogeneous. Okay, and a low inter-class similarity. So what that means is each cluster should be different from other clusters. So each cluster has to be heterogeneous, or you can say distinctive or independent of each other. Okay, the quality of clustering method depends on the similarity measure used by the method, as in its implementation and its ability to discover some or all of the hidden patterns. Okay. Alright, so let's look at the first algorithm, k-means clustering algorithm. Alright, so let's say we have two attributes. It's shown over here with the x-axis and y-axis. So we have all these the data points. Okay, it's all over, and we want to create a let's say two clusters. We want to create two clusters. So at the beginning, we have no idea how we're going to create two clusters. It could be like this, it could be like this, it could be like that. So we have no idea. So when you have no idea what to do, guess what? What do you want to do? Well, idea is do something. So idea is arbitrarily, okay, this is an important word, arbitrarily partition objects into k groups. Okay, in this example, let's just make two groups. Since we have no idea, we don't know which one to choose or how to create groups. So what we're gonna do is we just arbitrarily divide all this data set into two clusters. Okay, just arbitrary, totally arbitrary. It doesn't have to be anyway. It can be like this, it can be like that, it can be like this, or whatever. Okay, so arbitrarily partition objects into k groups, or in this case two groups. Okay, So once you have those two clusters, again, those arbitrarily create the two clusters, what we want to do is we want to calculate the centroid for each cluster. Okay, for example, in this case we have only two attributes, so we can calculate the center for x-axis and the y-axis. Okay, so basically you just add x values and calculate the mean, and add the y values and divide by the number of the data points, and then we can get a center, okay, or mean. So we can get a centroid for this group, let's say group A, and the centroid for this group, let's say B, okay. And then we have two centroid, okay. And the next step is we calculate the distance from each data point to those two centroid, okay. So one centroid over here, another centroid over there, and then we calculate the distance from each data point to those centroid, okay. Whichever is closer, and then we can reassign each data point or each object to a different group, okay. So initially, let's say this may belong to a group A, but after you calculate the centroid for B, this may close to the centroid of a group B, okay. In that case, we actually reassign this one to group B, okay. So once you have reassign each data object to the different two groups over here, and then we recalculate the centroid. We calculate the centroid again, okay, based on a reassigned data objects, okay. And then we calculate the distance again from each object to those two newly calculated centroid, and then whichever is closer, okay, and then we reassign each data object to a different clusters. So we keep doing this, we keep doing that until there is no change, okay. And then we have two new clusters. So this one is known as a k-means clustering. So idea is, again, we start from arbitrarily selected two groups. In this case, doesn't have to be two, it can be many. Also, it doesn't have to be two attributes, it can be many attributes as well. But conceptually the same thing. So let's say we have two attributes. Using those two attributes, we want to find the two clusters, no problem. So initially we just arbitrarily select the two groups, okay, and then calculate the centroid, okay, and from each from each centroid we calculate the distance for each data object, and then depending on which ones are closer to which centroid, we reassign each object to the cluster of its nearest centroid. We keep doing this, we keep doing that until there's no change, okay, and then we find two clusters, okay. Alright, so this is what this clustering method basically works, okay. So let me read this one again. So given k, the k-means algorithm is implemented in 4 steps. So k could mean 2, 3, 10, whatever, okay. And the partition objects into a k non-empty subsets. So initially we have no idea how to do it, so we just arbitrarily partition objects into k non-empty subsets, and then compute the seed points as the centroid of the clusters of the current partitioning, okay. So we can calculate the centroid. Basically we use a Euclidean distance, okay. And if you do not know how to calculate Euclidean distance, you may want to take a look at the book, or you may want to Google it. So simply speaking, just a distance, okay. And assign each object to the cluster with the nearest seed point. So each data object can actually change the cluster every iteration, and you keep doing it until the reassignment does not change, Okay, and then we have the clusters. Okay. In this example, to make example easy to understand, I'm using only one attribute. Okay, one attribute, and the data looks like this: 2, 5, 6, whatever. Okay. All right. So initially, so we want to make two clusters out of the data, 2 all the way down to 99. Okay. So initially, since we have no idea, for example, I'm going to have only these two as A, group A, 2, 5, group A, and everything else group B. Okay, and remember that was the first step in the K-means algorithm. And then we calculated the centroid. So to calculate the centroid, so we have to get these two, 2 plus 5, and get the mean, that's 3.5. Okay, and then we're going to get a mean average of all the way, everybody belonging to every data belonging to group B. Okay, and we calculate the average, that's 5957. Remember, next step, we calculate the distance from each data point to a new to a centroid. Okay, so we calculate the distance to 3.5. So that is what this one minus this in the square it, and then I get a squared value. So we get the distance between data point and centroid. Same thing over here. The distance between the data, this data object, to a centroid. We calculate that. Okay, and we do the same thing for every data point. Okay, and then what's the next step? And then we reassign each data point to a group which has the shortest distance from the centroid. Okay, so let's take a look. So this one's less than this one, so still A. Less than this one, so A. This is less than this, so A. This one less than 48, so A. 10.5 less than 45.57, A. 11.5 less than this, A. 19.5 and less than 36, A. And 22.5 less than 33.57, so A. But over here, 29.5 is greater than 26, so B is closer. Centroid of B is closer for 36. So we assign B. Okay. So as you can see over here, we started with two members in a group A. After one iteration, we reassign these objects to A, and then we keep doing this iteration. And then out of this one, we calculate the mean. Okay, so we calculate the mean of the new group. Okay, new centroid over here, and then same thing with the. So this one is A, so we have to calculate the mean for these. Okay, and then we calculate the also the centroid for group B. Okay. And then we calculate the distance again and compare the distance. Which one is the less than the other? We reassign the object to a different group. So now, if you look at this guy, it was a B, but after this iteration, this is actually closer to a newly calculated centroid. So we assign this object, this data point, to A up until over here. Okay, and then we do the same thing again. So next iteration, we calculate the new centroid, the new mean for A, new mean for B, and then we calculate the distance. Okay, and then we reassign each data point to a new to a new group, new clusters. So as you can see over here, 46 and 47. Okay, so these was a B previously, but now based on a new centroid, this point 45, 46, 47 now close to group B. So we I'm sorry, group A. So we assign them to group A. Okay, and then we do the next iteration. And next iteration, calculate the centroid again. Calculate the distance, compare the distance, and whichever closer to each centroid, and we reassign them to a new cluster. But as you can see over here, there's no change. There's no change. You can see that? No change. Even another iteration, there's no change. So when there's no change, we stop the iteration. So now we actually have two clusters. Okay, so 2 to 47 belonging to a cluster A, and 65 all the way to 99 belonging to a cluster B. Okay, I thought this is really interesting. So initially we start from something, okay, and then you may want to try different arbitrary numbers like that, and then still we actually found two clusters. Okay, whatever you want, so, and the iteration stops over here, and then we found the two clusters. Alright, hope it makes sense to you.